Hello, everyone, and welcome to Creating Custom Solutions with FME and Python. I'm Kaylin. I'm a desktop support specialist, and I am presenting with.
So I'll go in order of the slide here. My name is Laura. I'm on the FME Server support team here at SAFE.
And my name is Debbie. I'm also on the desktop support team here at SAFE.
Okay, I think we're just going to turn our webcams off for the rest of the webinar. Okay, so what will we be covering today? So we're going to go over a quick Python overview, and then we're going to get into some detailed examples, introduce you guys to ArcPy, and show you how to import modules. So the Python overview. What is Python? So Python is a general purpose programming language that's really well documented, free, and conveniently compatible with a ton of GIS applications. So one you guys may be familiar with is Esri's ArcPy. So this is just a sample Python script in case some of you weren't familiar with Python syntax. Both these codes do the same thing. We're just importing the OS, and then we're starting up FME Workbench 2018. The top one is using something called relative paths, and the bottom one is using double backslashes, but they do the same. So integrating Python and FME. Why do we see people use Python and FME? So to best answer this question, it's that Workbench isn't capable of performing a certain operation or transformation. So we can use Python when FME is a limiting factor. A lot of people use Python, like I said earlier, to leverage third-party modules or libraries. So a few common ones we see roll through are PyPDF, Panda, NumPy, ArcPy. We can call workspaces using Python outside of FME Workbench. We can automate data tasks. We can migrate scripts. Or perhaps a company's models or processes were originally developed using scripts and they'd like to be maintained. However, Python can get really tricky really fast, and we like to think that you might have a better overall experience if you're able to work directly within FME. So exactly what the last sentence says there, if you're thinking about writing a Python script to do something in FME, you should make absolutely sure that there's not an existing transformer already available. Okay, so if we were to use Python in FME, where could we find it? So we can find it in the form of startup and shutdown scripts, scripted parameters, and then we also have our two Python transformers, the PythonCaller and PythonCreator. So startup Python scripts. So this is a script that's executed prior to a translation. So it's executed after the mapping file has been parsed, after the log file has been opened, but before the readers have begun to do their processing. We see people use these scripts for many reasons. Sometimes they use them to check the validity of their database connections or web connections. You can create a backup of your source data. This is one I've been hurt by before, so this is the demo I'm going to do next. And you can also add custom logging. So in this demo, some of you might be able to guess, we're going to create a zip backup of our source data set and save it to our temp folder. So I'm just going to switch into Workbench here. Can you guys see Workbench?
Yep, I can see it, Kaylin.
Cool. Okay. Let me just find my source data. So we're going to read in a legal lot number shapefile. Okay. And then we can run and cache that data, make sure it doesn't give us any errors. All we're going to do is reproject to WGS 84. And then we can write to GML. So actually, I'm going to go add writer GML. And we're going to change the feature type definition to automatic. We can name the feature type legal lot numbers to mimic the reader, sorry. And then before I run the script, I'm just going to copy and paste my startup script. And so when we're looking for startup scripts, we can find them in the navigator under workspace parameters. scripting. And then you'll see we have options for startup scripts, Python scripts and startup TCL scripts, but we're gonna do the Python script and just paste this. So all we're doing here is we're pretty much creating a backup of our source data set, and then we'll be able to see this be loaded into our temp folder here. So if I go ahead and run this, oh, just save and run. So it looks like that ran with no problems. And if I bring back over my temp folder, so I'm just in temp, we can see legal lot numbers backup zip. So shutdown scripts. Very similar to startup scripts. So this is a script that's executed after a translation. And so this is executed after the writers have finished their processing and the log file is being closed. People use a shutdown scripts for many reasons. They can send an email to themselves if a workspace fails. They can move or make a copy or email data results to someone else. And they can scan logs, the log message for a particular condition. So maybe if you were working with rasters and you were wanting to keep an eye on memory, you could have an email sent to you when 90% of your RAM's used up. So in the next demo, we are going to use a shutdown script to open a file in its native or default application. So the workspace doesn't show anything overly specific. We're just going to read in a CSV, clean it up with an attribute manager, and then write to CSV. On my machine, I think I have CSVs to default open with Excel, so we should see an Excel pop up. I do have the workspace pre-built, but I'm going to walk you through it. So we're just reading in a CSV of public trees. We're cleaning up the attributes just to grab what we want, and then we're writing out. And you can see I have a publish parameter in here, or sorry, a user parameter in here, which we can actually see in our script as well. So you can see that the CSV file name is being pulled from our writer. You can adapt the script to open in not the default application if you wanted to open it in Notepad or Notepad++. And then you see it just automatically opened, and we can quickly see if our data results are correct. Okay, and I think I'm going to pass it off to Laura now for scripted parameters.
Perfect. Thanks, Kaylin. Yeah, so finish off the last section of parameters directly within Workbench here. So we're looking at scripted parameters. So these are basically a special class of not quite a user parameter within FME. So these are parameters basically where you can set the value of the output to come from the output of a Python script. One thing to note with these scripted parameters is that these will run before any startup scripts in the workspace. So the way the ordering kind of works is when you run the workspace, you have your user input that comes through any published parameters. That always gets kind of evaluated first. Right after that, we evaluate all of the scripted parameters and then the startup script, and then all the readers start to get processed. So the order of operations is good to be aware of, especially if you are working with workflows that require certain things to happen before other things. So just keep that in mind. One nice thing about these is that since they run after published parameter values are set, you can actually pull in values from other published parameters and use that to influence of what your scripted parameter is doing. So I'll show a quick demo of what that can look like in this case. I've got a workspace here. So this workspace is simply reading in a file geodatabase. I have 4 feature classes in this, and I'm simply going to log these. So my rest of my workflow could involve doing some actual data processing, but for the sake of this example, I'm just doing the reading piece. In this workspace, I have a set of user parameters already defined. So these are all published parameters that a user will get prompted to add values for when they run the workflow. in this case, I'm asking my user to supply the search envelope. So I want to know the minimum and maximum XY coordinates for the data that they'd like to read in. So they're going to be able to kind of pre-select the area that they're interested in getting data from. I'm also asking them to request which layers they'd like to get data from. So they can choose any number of the 4 layers that I'm reading in. But I have one catch. And that is if they choose to kind of read in a large area of my data set, maybe for my workflow, I'm actually creating a map. And in that case, if they're doing a large area, some of these layers don't really make sense to pull in. So the labels, for example, would be way too small if I'm pulling in a large section of data. So what I want to do is if the search envelope is too big, then I'd like to automatically remove some of these layers. And then if the search envelope is quite small, I can make sure those layers get read in properly. So I'd like to do that dynamically based on whatever the user selects. So I'm going to do that using a scripted parameter. So I can create scripted parameters just from the edit user parameter or the manage user parameters dialog here. So I can see the ones here at the top are the ones that I'm requesting as input from the user. So these are published. And down here, I have my private parameters, and I have one that's a Python script. For these scripts, you can choose your language. So it could be Python or TCL. Since this is a webinar about Python, we'll ignore the TCL option for the time being. So down below here, I can set my script. So I can run basically whatever I want in here. So what I'm doing in this case is I'm going to grab the values of the minimum, maximum XY coordinates and calculate the extent and just see how large of an area the user's requesting. I'm also going to grab the list of layers that the user selected. And then down below, I'm going to add some if statements. So if the extent is too large in this case, I have some disallowed layers. So I'm just going to automatically unselect my labels as well as my bus routes and bus stops. And then I'm going to change the value for that layers that I pulled in. If the extent is too small, I'm only going to disallow the labels in this case. So one thing I'll mention at this point is that you cannot change the value of a different published parameter within a scripted parameter. So here I'm pulling in the value from that layers parameter, but I can't actually set that value and change it. So all I'm doing here is I'm going to save this into a variable. And at the end of my script, I'm just going to return that value. So this will do that. It'll adjust my layers list and return that list of adjusted layers at the end. And now in order to actually make use of this script and actually apply this change to adjust how my workspace runs, I have to link this parameter to one of my other parameters in the workspace. So I've got my private parameter here, this feature types to read, and I have that linked to my reader here. So the feature types to read is actually coming directly from this Python script. So this is that same script there. So it'll do that calculation, look at my other parameters, and return an updated list of layers. So now what I can do is run this, just double check everything's set, perfect. So I'm going to make use of some presets in FME here. So I'll do the larger option first. So when I select a large area, I'm going to automatically remove the bus routes, bus stops, and labels from the layer selection. So I can see here the user has selected all 4. Now I can click Run. You'll see, even though I selected all 4 layers, only the Metro rail has been read in. I can see that at the top here in my log file. So I can see the published parameter has not changed. So I have all 4 selected. But in my script, I'm printing out the value for the modified layer list. And I can see here, this value only has monorail. So that's the value I'm actually passing in to my feature types to read. And I can rerun this again and select a smaller area to show the difference. In this case, all 4 are going to be read in because this area is within the tolerance. So I'm going to allow all of the selections to come through. So that's the basics there. So these provide quite a bit of flexibility. So you can really adjust these parameter values and add some pretty cool dynamic logic into this. So you can also kind of check, where your workspace is running based on some of the parameters for FME, for example. And if it's running on one system, you can set your database connection to be one value. And if it's a different system, you can have it as a different value and do that automatically. So lots of flexibility with these. I'll head back to the presentation now. So next, I'm going to talk about the two Python-based transformers within FME. So the first one we have here is the PythonCreator. So as you can see, this transformer does not have an input port. It simply has an output. So it's kind of similar to the creator transformer for other workflows. So this can be used to start off a workflow or a section of transformers within your workspace. The PythonCreator can be used to create any number of features to be used within downstream transformers. So I think one of the kind of key uses for this transformer is to be able to let FME connect to and read from data sources that FME maybe doesn't necessarily support currently. It could be maybe a proprietary data set or just something that we haven't gotten around to implementing yet. If there's a Python library for it, you can make use of that in the PythonCreator. So I'll show a quick demo of this one in action now. Let's bring up my workspace here. So I've got two examples. First one here, I'll just show a simple create example. So I've just placed this transformer into my workflow. When I open this up, you'll see by default we've got some code kind of placed in here already just to be a little bit of a helper when you're getting started. It's nicer than starting with a blank page sometimes. At the top here, we have the class to process features. So this just says what piece of this code we should run to start. So we're going to run this feature creator to start. You can modify this if you wanted to create your own thing to run. You could say, and do that. And then here you could just simply choose to run that as well. So that's totally customizable. I'll stick with the defaults for this. Oops, okay, I'm gonna cancel that. Here we go. And I'll go back in. Okay, so this is the template class interface that's kind of used out of the box. We provide just some samples. So we have an init function to start, an input one, as well as a close. So you can run the init at the beginning to kind of initialize any connections to things if you're connecting to a database in your script or anything like that. The input just for processing the actual data, and then the close to finish things up at the end. So all I'm doing in this feature creator is creating some very basic features. So I'm doing for X in range 0 to 10, so I'm creating 10 features. I'm going to set a new feature. Use FME objects, so I can create a new FME feature here. From my feature, I'll set a new attribute, just call it my attribute, and set the value to just a number from my range. If you're at all curious to know kind of what options you have when you're working with FME objects and what kinds of things you can do with your features, we have documentation for that, and you can find that from the help in any of these transformers. So if I go to PythonCreator here, you can find a link to the FME objects Python API. And so that'll give you access to kind of get an idea of what everything is and kind of all the different things you can do. So here for FME feature, I can see all the different options that I can work with and yeah, pieces to use. So here I've just got my simple one, creating some basic attributes and outputting those records. Down below, I have the ability to expose any attributes that I'm creating in my PythonCreator. So I'll just expose my attribute that I created here. And I can choose to run this. So this will simply create 10 dummy records, basically. So numbers 0 to 9. So for something a little bit more practical, I have this example here. So in this case, this is an example of using the PythonCreator to connect to a format that FME doesn't support out of the box. So in my case, I'd like to read a Microsoft Word document, but if I go to our readers here, we don't have an option for that. So I'm going to use a PythonCreator to make that happen. So just for some context, this is the Word document I'd like to read. So this just has lists of food trucks in the city of Vancouver and where they're located. So I'd like to be able to pull in this data and use that for processing. So I'll close that. So I found a Python library called docx that'll let me do this. So inside my PythonCreator here, I'm just importing that docx library. And down here in my input, I'm going to use that to create features to pull into my workflow. So first thing I'm doing is creating a connection to my document. I'm able to use this FME underscore macro values doc, and this points to the value of a published parameter. So I can see on the left-hand side, I have a list of all of the user parameters available in my workspace, and I can click on these to use those in my script. So it's basically a reference to the value that a user sets. That's the path to where my Word doc is located. And then I'm making use of this library to actually read that. So for this, I can read all of the paragraphs in the document, but I realized that all of the data that I want is actually in tables. So I'm going to read all of the tables in the doc as well. So for each table row in that document, I'm going to create a new feature in FME. I'm going to set one attribute for business name to the value of the first cell in the table. And then for this other one, I'm going to set the location to the value of the second cell. So I have the name of the business and the location where it is. And then I'm going to output new features, one for every row in each table that I read. And down below, again, I have my attributes to expose. So I'll expose that business name and location. So I can click Run here. So it asks me for the path to my doc. And there we have it. So I was able to scan that Word document and pull out the data that I want. So now that this is here and it's added into FME as regular features, I can process this and work with it just the same way as I would with any input from any other reader within FME. Okay, and last but not least, we have the PythonCaller transformer. So this one is basically the same as the PythonCreator in a sense. You can run any arbitrary Python script you'd like. The key difference with this is that it has an input port. So you can actually use this to process data that's already within your workspace. You can choose to run the script once per input feature. So if you have 100 records you'd like to process, you could run your Python script 100 times. Or the PythonCaller has recently been updated to have some group by or grouping options. So you could actually run the script on groups of input features as well. So I'll talk a bit about both of these and see how those work. So some key uses for this one typically would be if you need to perform some kind of task where we don't already have a transformer available built into FME. So maybe it's some complex statistical analysis or something like that, where we just don't have transformers that make it easy, but there are Python libraries available, so you could choose to bring those in and use those. Also good if you need to do complicated manipulations on lists. I find in particular if you're working with very, very complicated XML or JSON data, sometimes it gets really difficult to use directly in FME if you need to process lists within lists within lists. So sometimes the PythonCaller can help make that a little bit easier if you have a Python background at least. So let's get into a demo of this transformer as well. Bring up Workbench again. So similar to last time, I'll start with a very basic example and we'll kind of work our way up. So here I just have the simple PythonCaller. I'll open this up. So again, this is set up with a default class that you can use out of the box just to keep things a little easier. So it's the same setup as the PythonCreator. So we have this feature processor class, which is set in the top as well. It comes with an init function, an input, and a close. Key difference here is with the creator, each of these kind of runs once out of the box because the creator is starting off a workflow. The PythonCaller works a little bit differently when it comes to processing data that's coming in. So I'll show an example of what this looks like in a second, but I think it's good just to understand what this is doing and how it can work to better understand how to use this to work with input data. So here, so in my workflow, I've got my creator. This is sending multiple records into my PythonCaller. When a record comes into the PythonCaller, the first thing that'll happen is this init function will kick off and run. This only runs once, so this will happen once at the beginning, the first time a feature enters your PythonCaller, and that's it. Once init's been called, we call the input function. This gets called once per input feature. So this actually accepts the feature as an input, and you have access to all of the data inside that feature, all the attributes and all the geometries as well, so you can work with that directly. So in my case, if I have 10 records coming in, init runs once, then input will run 10 times, once for each record. And then at the end, we have this close function, which will run once at the very end. So it's good for being able to do some cleanup at the end. So what I've done just for the purpose of this example is just I've added some print functions into each of these, So I'm going to print init when I get to the init function. I'll print each an attribute value from each of the records coming through, and then I'll print once for the close at the end here. So if I run this and take a look at the log file, super exciting webinar where we're looking at log files in this case, but I think it's important to see. So at the beginning here, I've got this init. So you can see the init ran once. I got 4 features coming in. Init ran once, and then input ran 4 times, once for each record. And I was able to pull an attribute value from each of those, showing that they are different. And then down at the bottom here, I have my close. So that ran once at the end. So it's good to have the init and the close for the setup and cleanup, and then the input for actually processing the data itself. So what does that look like when you get grouping involved? I'll attach my input here. So for this example, I have generated a few records. I've got 8 records coming in. Each of them has a group attribute. So there's 2 groups here, group 1 and group 2, and they're coming in kind of in random order. And so I'd like to be able to process them. So everything in group 1 gets processed together, and everything in group 2 gets processed together, and they're processed separately. So I can do that in my PythonCaller. So at the top here, we have this group processing option. You can choose to group by. So this works the same way as the group by in most of our other transformers. You just choose an attribute that designates what the groups will be and how to group those features. You can choose to process at end or process when group changes. So here I'm going to wait till the end. So all the data is going to come in, and then it's going to be processed by group after that. So the way this changes things in the Python script isn't too much actually. So first we have the init, so this will run once at the beginning as soon as the data starts coming in as usual. The input again gets run once per input feature, so this one doesn't care about the groups. The next one is close, that runs at the end once, and we have this definition here for process group. So this one runs once after all of the records from a single group have come in. So for my example here, I've got all my records coming in, and then everything from group 1, for example, will come through. When group 1 is done and it's all in this transformer, this process group will happen, and then I can do processing on that group. What I need to do, however, is create a list of features to pass into that group function. So at the init, I'm creating a list for my feature list. For my input, I'm just going to add my features to my feature list as they come through. These will come in order by group. So the transformer will take care of that. So when this is done, I'm going to use this in my process group. And so I can run all of the data for each group directly in here. When I finish this group, I'm going to clear it, and then I can start processing the next group of features. So I can run this and just show what that ordering looks like. Oops, got to run all over again. Here we go. So I can see here I've got my init that ran once. My inputs ran one by one as the inputs came through as usual. One difference here, though, so you can see these groups came in random order, so group 1, 2, 2, 1, etc. But when they came into here, they're actually ordered by the group. So FME kind of took care of gathering everything from group 1 and sending them all in together in order. So everything from group 1 came in through here. Once group 1 was finished, the process group function kicked off. So at this stage, I could then take that list of items in my group and process those together. So here I just iterated through that list to show that I could. Once group 1 is finished, we go through the inputs for group 2. So we go back to that input function. And then I can process that one as a group, do all that ordering, and then close at the end. So that's the basics of how that works. So it's powerful if you do need to use grouping in your transformers for this. So last example in this. So I'm just going to show an example of adding functionality to FME using a PythonCaller transformer. So for this example, I'm using a custom transformer that I downloaded from the FME hub. So what this transformer does is it does kind of a fuzzy matching on input strings. So in this case here, I've got my input data. So I'll run this just to show you. I have a few records. So they're just names. So one of them has a typo in them. And what I'd like to do is use this fuzzy duplicate remover to kind of be able to handle typos in my data set. So FME doesn't have a transformer that can do that out of the box, but we do have this one. And there's a Python library that can make this work. So in this transformer, I'm making use of a PythonCaller and the difflib library. So I'm just importing that, and then I can do my matching based on the strings that are coming through and find out how closely they match. So if it's a 90% match versus a 20% match, I can see how close they are, whether or not they should be a duplicate, maybe perhaps with a little typo in it. So I can run this, and that'll find all of the unique and duplicate attributes. So here I've got 2 unique ones, Laura and Fred, and then 1 duplicate, which would be Laura with the typo in it. So this transformer can accept an input with the filter ratio, which will change depending on what the Python script finds. So if it's a 70% match or better, we'll consider that a match. And if not, it'll be considered unique. So it's just a great way to add additional functionality and make FME even more powerful than it already is. Okay, so that's the end of my demo here. So I'm going to pass it over to Debbie now to talk about Python compatibility.
Okay, so I'm going to talk about Python compatibility in FME. FME 2021 supports Python 3.6 to 3.8 and also provisionally supports Python 2.7. It is available as an optional install component on Windows, so it is a Windows-only support for now, and also supports using the Python interpreter that's included with ArcGIS products. So if you use the ArcGIS interpreters, you can use the ArcPy library, which some of you may be already familiar with. So different versions of Python are supported depending on which build of FME you're using. So I would recommend checking the documentation or going to FME objects directory in the FME install directory. You'll see a few folders in there that start with Python, and it would indicate that these Python versions are supported. So unfortunately, you can't use, say, 3.9 in FME 2021 because the max version of Python supported in FME 2021 is 3.8. So you may know of a setting in FME called the preferred Python interpreter. So this per user setting controls the default Python compatibility value for new workspaces. It also controls the interpreter loaded for Python's FME Python's interactive shell, and also Python pips utility. I believe Laura will go through an example of this later on. And you can also use the setting to specify a custom interpreter instead of using the interpreter bundled with FME. Note that this interpreter setting does not affect which Python interpreter is loaded for existing workspaces. Find that this is a common misconception. So what can you change to do this? So you can do this with the Python compatibility parameter in a workspace. So this parameter specifies the level of compatibility your workspace or custom transformer has with different versions of Python. You can, as I mentioned, you can use this to control which Python interpreter is loaded by FME when running a workspace, and this parameter can be found in the navigator under Workspace Parameters Scripting. And this parameter is workspace specific. So one workspace can load Python 3.8, another workspace can load Esri's Python 3.6, for example. So choosing a Python interpreter. We've got a few different options. I would recommend using Python 3 simply because Python 2.7 is end of life. FME 2023 will drop Python 2.7 support. So if you've got any legacy scripts that still depend on 2.7, I would highly recommend upgrading these scripts to be compatible with Python 3. Of course, there are still other considerations. If you have dependencies, you may need to choose a specific Python version. For example, if the module you're running calls on a DLL that is built with Python 2, then it won't work with Python 3. And for example, ArcGIS desktop ArcPy is Python 2.7 only. So if you are using desktop ArcPy, then you need to use Python 2.3. So Python on FME Server, it should be very similar to desktop. Engines use a workspace's Python compatibility parameter to determine which Python interpreter should be used. If a currently running engine has loaded an compatible interpreter, the engine will be restarted automatically to load a compatible one. So for example, the engine has been using Python 2.7, and it receives a workspace that uses Python 3, it will automatically restart to load Python 3.8. So no user action is required. It will be handled automatically by FME Server. So just to summarize, Python in different operating systems. So FME is supported on Windows, Mac OS, and Linux. So on Windows and Mac OS, it uses FME's bundled interpreter by default. On Windows, you can specify a custom Python interpreter. However, on Mac OS, you cannot specify a custom Python interpreter. On Linux, the system interpreter is used, with the exception of FME 2021, where there is no Python 2 support. So it will only use the Python 3 interpreter on Linux systems. And you can also not specify a custom interpreter in Linux. Using ArcPy with FME, we've got lots of questions about this. ArcPy is a package that provides geographic data analysis, data conversion, data management, and map automation with Python. It is part of the ArcGIS suite. FME supports working with Python 2.7 and 3 versions of ArcPy on the Windows platform only. So unfortunately, we cannot use ArcPy on Linux. It requires a licensed installation of ArcGIS Desktop, ArcPro, or ArcGIS Enterprise in order to use with FME. Usually Enterprise is for FME Server. So in order to use ArcPy, a workspace's Python compatibility parameter must be set to the appropriate Esri ArcGIS option in order for it to work. So I will go through a demo showing how to use ArcPy in FME. So I have a simple script here in the PythonCaller, which calls ArcPy, checks the license to see which one is available, and then it prints a message to the log. So it's very simple. If no license is available, an error message is logged. So in order to use ArcPy, you need to make sure that ArcGIS Pro or ArcGIS Desktop is installed and licensed on the machine. If you have Arc Pro installed, it needs to be a per machine install. So when installing it, you need to have selected the anyone who uses this computer option in the installer. You also need to make sure the bit version matches the ArcGIS product. So if you're using a 64-bit FME, you need to have Arc Pro, or you need to have the 64-bit background geoprocessing installed. You also need to ensure the version of FME that is running the workspace is compatible with the ArcGIS product. We have an article here which lists which ArcGIS versions are compatible with which FME versions. And lastly, you need to ensure that the Python compatibility parameter is set to the correct option. So I have ArcGIS Pro 2.5 installed, so I need to choose the Esri ArcGIS Python 3.6. So I'm just going to run this workspace. So I have a parameter which I can select which license type, and I'll just choose advanced and run it. So here you go. We've printed out a message to the log, which says the Arc info, which is the advanced license, is available. For example, if I chose a standard license and ran it again, it will give me an error because I do not have access to a standard license. So that is it. Actually, I just want to mention we've seen some users leave the Python compatibility setting to an Esri ArcGIS option, which you can do. However, it's not recommended if you're not using ArcPy or you don't need it for other reasons, because even if you don't have Python set in the workspace, if this Python compatibility setting is set to an ArcGIS one, the startup of the workspace is slower because it does a license check. And it also uses a license, an ArcPy license, ArcGIS license, which may be a limited supply for some organizations. And that is it for my demo. I will pass it off to Laura.
Hey, thanks, Debbie. Yes, I'm just going to wrap it up and talk about importing modules for Python. So what if you have a Python script that requires a module that's not part of the standard library from Python? What can you do and how do you make that work in FME? So I'll talk about both desktop and server for this one. So yeah, basically out of the box, you can use anything from Python standard library with no extra work. You can simply import them, OS, file import, statistics, whatever it is you need to use, and it'll run no problem wherever you publish that workspace, as long as there's a Python interpreter available. But for other things, you'll need to make sure to install the libraries that you need in order for FME to be able to use them. So you need to install them for the Python interpreter used in your workspace. So how does that work? So for packages that are publicly available and accessible through the package installer for Python in pip, you can simply run a command to pip install those packages. So this is what the command will typically look like. In this case, this is the Windows version of it. It'll work on Mac and Linux as well. So, what you need to do is find the path to your FME executable. So this would be in your FME installation directory. And you can run fme.exe python. And this will automatically run with the default Python interpreter for your system, for your FME, sorry, for your FME in your system. So this interpreter gets picked up from the setting in FME options. So under FME options, if you have Python 2.8 selected there, this will run automatically with Python 2.8. If you do that for 2.7, it'll run with 2.7. So it'll use whatever your default interpreter setting is for Workbench. So you can run this, you can then run pip install, find your package name, and then set your target. So one of the key things here is making sure to set your target to the right location. So key is being able to place your package files into the correct location for FME to be able to use them. So there are a few places you can actually put these, but I'm going to say for best practices, the best place to put them is these two locations. So on FME desktop, you have your FME user folder. So it's typically found in your documents folder on Windows, and I'll show it what it looks like on Mac here in my demo coming up. You'll find that in your documents under FME. You'll see there's a plugins Python folder there by default, and that's the location where you'd need to install any Python libraries or modules or packages or anything that you're using. On FME Server, they go into resources. That's your system share folder under engines, plugins, Python. So I'll show what that looks like coming up as well. Yeah, so let's do a quick demo of this. So I've got a workspace open here, simply using a creator and a PythonCaller. So in this PythonCaller, I am importing a module called PyFiglet. So this is actually just used to create ASCII art. I had to find one that was fairly small so I could do a demo of actually uploading this to FME Server and not make us all wait here for 5 minutes while we uploaded 10,000 files. So this is the one I went with. So this one's not part of the Python standard library. So on my system, what I did to install this in order to be able to run this on my MacBook is I ran the command, so the pip installed this. So at the top here, this is the command I ran. So I found my location where my Python's installed, ran this Python pip install, pyfiglet, and set my target to my FME folder. So that on Mac is found in your users folder under library application support. And I just pointed it to there. So when I ran this, it installed directly to this. So this folder looks exactly the same as the FME folder in my documents on Windows as well. So it has this plugins, Python, and you can split it out by Python version as well. So in this Python folder, you actually have two options. So if you're using a Python module or library that would be compatible across multiple Python versions, you can actually just place all of the library files directly in the root here under Python. That way, any Python interpreter that gets loaded will have access to those files, so it can run with that module no matter what. If you're working with a library that has functionality that's specific to a particular version of Python, so for example, I think there's compatibility issues, particularly between 2.7 and say 3.8. So you could have a Python 2.7 folder here, so it will only find it if the Python 2.7 interpreter is being loaded. So here I just placed mine in my Python 3.8 because I know I'm running with my Python 3.8 interpreter, and this is where my pyfiglet files have gone, so FME can pick them up. So here I could then run this workspace. All I'm doing is printing some ASCII art into the log file for this case. You can definitely find more useful libraries. I'm sure there's much more powerful things out there for very complicated scenarios, lots of statistical analysis and all that fun stuff as well. So here I'm just printing hello to my log. That's great. So I'm going to publish this up to FME Server, which I have already done. And I'll just show what this will look like on the server side. So I've got my custom module workspace here. I can try to run that. So it's running exactly the same workspace I just created. I can see in my server environment, this is failing. So if I open this up and check out the failure, I can see here I've got my Python exception, module not found error, no module named pyfiglet. That is because I have not installed this module for FME Server. So FME Server has no idea what this is or where to find it. So I need to make sure I'm making these files available in the server environment as well. And I can do that simply by going into my resources folder and including it here. So this engine folder here is just a shared resource location for all of my engines. This is equivalent to that FME folder in my documents. All of the engines on your system will have access to this, so no matter where the engine's located, it'll be able to see anything located in this folder. So I'll go into my plugins, Python, and I have a Python 3.8 folder created already. And then I can grab my Python files and drag them in here. So I'll wait while it uploads at the top here. Almost there. Done. So now that those are uploaded, I can go back to my workspace and run that again, and I can see that this should complete successfully. Yes, there we go. I can view my details, check my log file, and see what's left of my ASCII art. Also learned while doing this that the pipe is used as a delimiter for these log files, and they're displayed on FME Server. So if you're doing ASCII art, it's probably not going to turn out, so be aware of that. Yes, so that's kind of the basics there. So if you do need to use a Python module, you will need to make sure you have access to resources in your FME server so you can put the files in there so all of the jobs and engines can access those files. Yeah, so I think that brings us to the wrap up for this webinar today. So we have a list of some pretty good resources here. So we've got a range of things. We've got a tutorial on the Python and FME basics if you're looking on where to go to get started. Some details on working with Python scripted parameters, how to install packages for desktop and server, and then also links to our Python FME documentation if you'd like to know how the API works and what you can do with it, and then a link to just Python documentation in general as well.
Awesome. So we have a community badge for everyone today as a thank you for joining us. So you can visit fme.ly/webinar-badge, and today's code is on the screen, and I will also leave it in the chat in case you missed it. And yes, we do have some time for Q&A. Do you have any question that you want to address live?
Hi. Yes, we did have a few questions. So I'll start asking them. And I guess Debbie or Kaylin, if you want to jump in with answers for any of these, feel free. So one of them was related to setting up, basically if you're installing custom modules for Python, there were quite a few questions just asking how to do that and where you place those files. So hopefully we covered that a bit in the webinar. But we do have a page in our documentation that talks about that as well. So I can share that out in the chat in case anyone needs that. So one question, will Python 3.9 be supported in FME 2022? Does anyone know?
Yes, Python 3.9 support has been added to 2022 already. It's available in beta if you would like to test it out.
Perfect. Thanks, Debbie. Let's see. There's another one about how do you debug Python code within FME? Anyone have some tips on how to handle that?
Yeah, I can talk to this one, Laura. So it's best to test your code outside of FME and make sure it's working fine and then bring it into FME afterwards.
Perfect. I had one question related to the Esri ArcPy compatibility setting. So if you have it set in your workspace and then you publish that to FME server, will it still apply there? I can answer that, and that's yes. So when FME server runs a workspace, if it has that Esri compatibility flag set, it will look for the Esri ArcGIS or the Esri Python interpreter and load that there as well. Any other questions? I see one. Can FME utilize the ArcGIS API for Python?
Yes, I believe that is yes.
Yeah, definitely. Yeah, so that's just a setting in Workbench there you could turn on if you wanted to use that, and you could import ArcPy and use those libraries. Yeah, does anyone else see any other questions that would be worth covering?
There's one about, I have ArcGIS Desktop and ArcPro on the same machine, but they use different license managers, and how can I force it to use the Pro license? So there's a new workspace parameter called the Esri ArcGIS Compatibility in 2021 that lets you have control over which ArcGIS product your workspace will check out.
Perfect. Oof, okay, so I see a bunch of questions coming in here in the questions panel now. Yeah, somebody asking, you'll have to install ArcMap or ArcPro on machines which host FME Server for the license. Yes, so if you need to use any ArcGIS Python tools or anything that requires an ArcGIS or Esri license to run, you do need to make sure you have ArcGIS installed on the machine where the FME Server engines are running. I have somebody asking about using Git. So can you Git clone the Python code for FME transformers from Git repositories? I don't know, Debbie or Kaylin, have you worked with Git with Python and FME much?
Not personally.
Okay, yeah, so we don't have too much familiarity with that. Yeah, I guess the trouble with, if you're putting Python code into something like a custom transformer within FME, the only way to package that Python code with the transformer is to have it inside something like a PythonCaller or a scripted parameter. So that kind of immediately makes it difficult to use Git with FME transformers just because of the way the transformers are stored. So it could be tricky. But if you want to store the code outside of the transformer and import that, that could potentially work. Any other questions that you see? There's one about a script that creates a version in SDE. Should I use that script in the startup Python, or would a PythonCreator work?
I think this is more, both would work, I think. More personal preference as to where you would like to put the script.
Right. Yeah, I guess it kind of depends on the order in which you want to do things. If you're using like a regular reader, you'd probably want a startup script so that it ran before the reader connected to your SDE. But if you're using like a feature reader, you could use a PythonCreator first and pass that to the feature reader and then read the data.
Yes, that's right.
Yeah. Okay. And oh yeah, we had a few questions about the webinar. It is recorded. So we will be sharing out that link, I believe, after the webinar. So you'll get that. Okay. Yeah, I think the questions have slowed down. Yeah, I think that's it for now. Thanks, everyone.
Yes. Yes, thanks everyone for joining our webinar today, and also to our presenters. There's a survey that will be launched at the end of the webinars, and we always love to see your feedback. And with that, I will leave the webinar open for a few minutes longer, just in case any questions come in or you want to save any links from the chat panel there. And if there is any question that we are not able to answer in the webinar today, we will be sure to follow up with you. You can see all the links and also the webinar badge code in the chat panel. And that's it. Hope you all have a great rest of your day, and bye for now.